Good day, doctor. I'm Sitara Selvam, and this is my answer for question number 5. This is my question, and this is the raw data. For the experimental design, we conducted a survey to collect data from 12 UMS students, and their body height and gender was recorded. And for the data type, the body height is scale data, and for the gender it's a nominal data. And his research question was whether the body height of student related to the state and gender. So I changed the research question to, is there any significant effect of gender and state on body height of UMS student? For the hypothesis, first null hypothesis is there is no effect of gender on body height of UMS student. And the alternative hypothesis, there is an effect of gender on body height of UMS student. For the second null hypothesis, there is no effect of state on body height of UMS student. And the alternative hypothesis, there is an effect of state on body height of UMS student. For the third null hypothesis, there is no significant effect between gender and state on body height of UMS student. And the alternative hypothesis, there is an insignificant effect between gender and state on body height of UMS student. For the criteria, alpha is set at 0.05. After that, I organized the data in table form in Excel, student ID, gender, state, and their height. And I saved the file in CSV form. This is the data. And I plan to conduct two-way ANOVA tests. So first, we have to set the working directory. This is the command. And second, we have to name the object, gender, state, height, read CSV, and the file name. After that, this is the summary of the object. And then before conduct the normality test, we have to separate the data into several subsets. So the combination factor, and then this command to make gender and state into one factor. So this is the command, and after combining, the data will look like this. This is the combination factor. And after that, we have to combine these to the data set. So the object name, combine, and then cbind the object name and the combination factor. So it will look like this. Next, before the normality, we have to create subsets of data from the original data to perform the normality test. So these are the comments: male Sabah, female Sabah, male Terengganu, female Terengganu. And then we can proceed to normality test. This is the commands for normality test: male Sabah, female Sabah, male Terengganu, female Terengganu, and the variable is height. And next, we have to load library car to perform leave-in test. To perform leave-in test, this is the command: the object name, height, the variable, against the object name and the combination factor. So after that, to organize the data in a chart, so we do the ANOVA in a box plot. So this is the command: box plot, gender, state, height, the variable height, against gender, state, height, the variable state, and this is the symbol plus because we're combining the variables. And after that, to label the data, this is the command. So this will be the outcome. And next we have to perform ANOVA, and this is the command for ANOVA, two-way, and AOV is for ANOVA. And then to see the interaction between gender and state, this will be the command. We have to just copy paste and then add the interaction, and also changing these to multiple symbol. So this is the normality test result. So for height, male, female of Sabah, and male of Terengganu and female of Terengganu. If we see the p-value, it's 0.2983, which is more than the alpha value 0.05. For the female Sabah, the p-value is 0.6369, which is also more than the alpha value 0.05. Next, for the male Terengganu, the p-value is 0.3631, which is also more than the alpha value 0.05. And lastly, female Terengganu, it's 2.2, which is also more than the alpha value. So all the data are normally distributed because the p-value is more than the alpha value 0.05. Next, this is the result from Levin test for homogeneity of variances. If we see the p-value, it's 0.4119, which is more than the alpha value 0.05. So there is no significant difference in variances between samples, and variances of sample are equal. And these are the summary from two-way ANOVA test. So for the gender, the p-value is 0.0556, which is more than the alpha value 0.05. And for the state, the p-value is 0.5300, which is also more than the alpha value 0.05. And from the summary of two-way ANOVA interaction, the p-value is 0.1116, which is more than the alpha value 0.05. And this is the box plot, the outcome. We title it two-way ANOVA test, and for the x-axis I put combination factor of gender and state, and for the y-axis height in meter. So if we see the box plot, we can say that the data is normally distributed because there is no any outliers. And if we see the median, it's almost in the middle. So as a conclusion, there is no significant effect between gender and state on body height of UMS students. That's all for me. Thank you.